Hello and welcome to the Data Engineering Podcast, the show about modern data management. When you're ready to launch your next project, you'll need somewhere to deploy it, so you should check out Linode at dataengineeringpodcast.com/Linode and get a $20 credit to try out their fast and reliable Linux virtual servers for running your data pipelines or trying out the tools you hear about on the show. Continuous delivery lets you get new features in front of your users as fast as possible without introducing bugs or breaking production, and GoCD is the open source platform made by the people at ThoughtWorks who wrote the book about it. Go to dataengineeringpodcast.com/GoCD to download and launch it today. Enterprise add-ons and professional support are available for added peace of mind. And go to dataengineeringpodcast.com to subscribe to the show, sign up for the newsletter, read the show notes, and get in touch. You can help support the show by checking out the Patreon page, which is linked from the site. To help other people find the show, you can leave a review on iTunes or Google Play Music, tell your friends and coworkers, and share it on social media. This is your host, Tobias Macy, and today I'm interviewing Bryon Jacob about the technology and purpose that drive data.world. So, Bryon, could you please introduce yourself?
Sure, yeah. Thanks for having me on the podcast. My name is Bryon Jacob. I'm the CTO and one of the four co-founders at data.world. The four of us had all known each other and worked together in various combinations at a number of companies here in Austin over the last 20 years. And so we brought a lot of different experiences and, our networks and our kind of experiences starting and working at other companies to bear to data.world, which I think we would all four agree is definitely the most ambitious company we've started.
And how did you first get involved in the area of data management?
Yeah, so for me, it's mostly been as a consumer or as an implementer of data management solutions. Earliest on, I was in grad school. I studied, I was studying artificial intelligence, but 20 years ago. So a lot of the things that are popular now, but in a much different form then, and was interested through AI and a lot of the representational things that really became what is the semantic web. But after leaving grad school, I worked for a few different companies. I worked for a company called Trilogy here in Austin, which was a big enterprise software company, did a lot of configuration management, and I had kind of gravitated toward just solving some of the hairier data integration problems that we had, kind of integrating that technology into various data management layers at our customers. I worked for a short while at Amazon. Where there I worked on their dropship team, which was basically, again, data integration. It was solving the integration between Amazon's inventory systems and third-party warehouses that serviced some of their goods. And then I spent the last 10 years before starting data.world at a company called HomeAway, which is an online marketplace for vacation rentals. What was kind of technically interesting about HomeAway and really what kind of drove me through a lot of different projects there over 10 years was we started the company really as a roll-up. There was a lot of smaller regional vacation rental listing sites, and the business was really started to kind of aggregate those into a single online marketplace. And so over the time I was there, we made over 30 acquisitions and got to really deal with the problems inherent in integrating 30 existing platforms. And it was kind of over the same, 2006 to 2016, the same period of time where we were standing up a data lake and real building big data solutions, and then building up a data science team, and got a lot of experience through the practice of getting that platform pulled together.
Yeah, it sounds like it prepared you quite nicely for the work that you're doing with data.world as far as being able to merge and incorporate and host disparate data sets that aren't necessarily in the same types of formats or even really sharing any common ground as far as the foundational layer.
Yeah, a lot of the problems that just kept coming up over and over again, it's like while we were very, practically solving these data integration problems and, trying to keep up with the best practices and the state of the art, I was always kind of in the back of my head watching the semantic web world and wishing that there were more of those tools in the mainstream, that there was more of this, there's this really powerful technology for normalizing and standardizing data. And it's just, it was it seemed like after a while that it was getting further and further from the mainstream. Even as that technology was developing, so many other techniques that had lots of, that were just kind of short term, easier to consume, and worked better with the existing kind of standard best practices kept coming along, and more people were getting into data. So there were increasingly more tools kind of just aiming at the lowest common denominator. Where some of the early ideas for data.world came from were really just, thinking about how even some of the tools that people are doing in analytics, in data science, and in different kinds of analytics roles that are, dealing with CSV data and spreadsheet data, the kind of things that are extracted from bigger systems or pulled from APIs, that data is almost completely unmanaged the way it's worked with today. And it, just started seeing opportunities where really putting a standardizing layer that lets you start to embed some knowledge and some metadata into that data could be a way to really level up the way that people were working with data in a way that leveraged that powerful semantic web technology without necessarily having to, hit everyone over the head with it and make everyone become an expert in this fairly esoteric technology in order to benefit from it.
And that fits nicely into what you're doing with data.world as far as being able to provide a foundational data layer for a lot of different types of open data to be able to be hosted and analyzed and linked together. So I'm wondering if you can just describe a bit more about the work that you're doing there and the mission of the company and how your status as a B corporation ties into that.
Yeah, as we started kind of brainstorming the business ideas, it kind of evolved from, it'd be great if there was a platform that did this, but, what does it mean and what would the business be and what's kind of the implications of it? We started really, hitting on the idea that there's a flywheel effect that you really go, there's not a lot of data that exists in this linked format where you can actually, effortlessly move from one data set to the next because the metadata tells you that you're about the same topics and that you've got those semantic connections. There'd be a lot of value that could be unlocked if there was more data that worked like that. And people do this work all the time, right? It's a common meme that gets thrown around that, 80% or 90% or 70%, whatever percent people throw around of the work that people are doing in data is just in finding data sets, cleaning them up, making them work together. And, I guess the insight we started having was that's knowledge engineering, right? That's the same kind of work that ontologists are doing when they're kind of curating data and linking it together, but people don't call it that, and they don't really necessarily know that that's what they're doing, and that work often gets thrown away. Like at best, maybe that knowledge work is in some reusable Python code or R code somewhere, and it's checked into a Git repository so that a team can reuse it. But by and large, that metadata is not getting attached back to the data in a useful way, so that the next person who comes along to use that data asset can kind of pick up where the previous person left and benefit from all that work that had already been done. So, we started seeing the data would be more valuable if it was better linked. The people are actually doing the work required to link it, but we're not capturing the output of that. And if we could start to build tools that really, understand the workflows people have with data and iteratively improve those workflows rather than trying to be something completely different, just try to be a better way of managing that data workflow, we could start to get in the middle of some of those pieces of work, capture that knowledge, feed it back into the data, which makes the data more valuable. And then that flywheel could start to go where you really get, the network effect, both in terms of connecting up teams of people working on data and better connecting the data. And as we started thinking about that, it became pretty quickly evident that this would be a lot more powerful and a lot more valuable of an asset for the world if it was really, done in an open fashion where we're linking up the world's open data. The data coming from governments, the data coming from academia, the data that companies are starting to open up and share, and I think that's going to be a really big force going forward. We thought that this would be a platform where if we could find an economic model that let us allow most of the users on the platform to use it for free to work on open data, forever, then we could start to really kind of level up the way people work with data, level up the data itself, make the open data of the world more valuable. And really that would provide a huge business value to folks because getting your company's private data adjacent to all that open data in a format where where you can find the relevant open data that helps solve the problems that you need to solve just by the fact that your data is about the same topics and it's linked. Just all of those things would kind of converge, and then finally then coming back to the B Corp, we started looking at the B Corp structure, and it was a pretty easy decision for us really. Once we kind of educated ourselves about it, and I have to give a lot of credit to our investors, because when we first started the company, we hadn't really had the insight about a B Corp. We just incorporated it as a standard C corporation, and then we got really excited about the idea of a B Corp and thought it made a lot of sense, and that required all of our investors to kind of educate themselves and get on board with making that change. But it wasn't hard. We kind of explained how it aligned with the mission of the company, and how it really gave us a lot of credibility, a lot of standing to be able to say that we are this is still a for-profit company, but we have this social mission that's going to be a big part of the decision making we're going to make, and it was pretty easy to get everyone on board.
And the underlying platform that you've built for being able to host all of the different data sets, both open and private, for linking together, I'm sure has evolved a lot of complexity given the different sizes and types of data. So I'm wondering if you can just describe what that architecture looks like and the different tooling that you're using to be able to support those different data sets.
Sure. Yeah. Something we honed in on, like almost from the very beginning, was we didn't want to be closed off as to what we considered data. Our platform's really best. We've spent a lot of time optimizing around how we deal with structured or semi-structured data and turning that into a queryable database. But there's a lot of value that people get in putting things like images and PDFs, even audio files, things like that, into a data set alongside that structured data to help other people understand it. So, we first kind of optimized around, let's just make sure that from a certain layer, you could look at a data set as just storage, right? You could just put bytes in and get those same bytes out, and those can mean what you want them to mean. And then we can start to observe what are the file types that people are seen to be using and getting value from, and we can handle those, to the best of our ability. So we started with a certain set of structured file types, and we started adding more as we started seeing more signal. Similarly, on unstructured things, we started looking for, people were putting a lot of source code in, so let's put some syntax highlighting in and put in some things to help people visualize that within the platform, and so on. But then regarding structured data, the way our architecture works around making all of that queryable is, so as I mentioned, everything's based on semantic web technology. So what we do is we build an RDF model of any structured data that comes in. So if you're putting in data that is already in one of the serialized forms of RDF, we can just load that up directly. And if you're putting in other data that looks graph-like, we can convert that to RDF. Data that's tabular in nature, which is by far the majority of what we see. So CSV files, Excel spreadsheets, relational database dumps, some geo formats that have kind of a tabular structure in them. We parse those files. We build an RDF model based on the CSVW specification, which is a spec put out by W3C around modeling tabular data in RDF. And what this lets us do is basically build a logically, the way you can kind of look at data.world is it's a single queryable database where each data set represents a graph, if you're thinking of it as a graph database. And at any point, you as a user have access to some portion of that graph. You have access to your own private data, any private data that another user has shared with you. So if you're a member of an organization, you'll have access to that organization's data sets. If somebody has added you as a collaborator, you could think of this very similar to a collaboration platform like GitHub. You might have organizations you're a member of, and you might have one-off collaborations that you participate in, and then all of the open data on the platform. And you can query that data as though you have access to all those graphs. The native query language of semantic web, and therefore of our platform, is a language called Sparkle, SPARQL, and that's another W3C standard query language for this graph database structure of RDF. So you can use, and one of the nice features of Sparkle is it has really great features built in for doing that kind of federated querying. So you can query across any data sets in our platform, but then also to public Sparkle endpoints. There's a bunch of examples of that. The easiest one kind of explain for maybe an audience who doesn't do a lot of this linked data is one called Dbpedia, which is basically a linked database of structured data that is extracted from the pages that people edit on Wikipedia. So if you think about all the information you might have on Wikipedia that you could go click through and read as a person, imagine that all that data is kind of pulled out into a structured searchable database. And that database is open on the internet. You can federate between data.world data sets and that database. And then one thing that we've done, which is, by far, I get really excited talking about the Sparkle endpoint, all this RDF, and me and tens of other people in the world care. But a lot of the data that's in our platform is tabular in nature, and a lot more people understand SQL than Sparkle. And so one of the things we've built is basically a SQL to Sparkle transpiler, so that you can, just like you can use our platform as though it's a big distributed graph database where you have access to a portion of the graph. If there are tables that are stored in each of those data sets, you can query them with SQL the same way you would a large distributed relational database.
And how has that architecture evolved from when you first launched, and what are some of the scaling problems that you've had to deal with as you have grown the platform and the variety and amounts of data that you're dealing with?
Well, we were very fortunate to kind of start this with a pretty experienced team, so we've been really deliberate around what we chose to scale. So early on, we made a point of making sure that, the thing we wanted to optimize first for was basically, account and resource level scale. So we wanted to make sure that whatever we do, it's going to be able to quickly scale up to support any number of users, any number of data sets. We didn't want to suddenly have the fortune of, finding a great viral connection to a community and growing by a huge amount of users and have everything fall over, especially since we knew we had the resources to not do that. So the trade-off we made there was we started with relatively small limits per data set. So we kept the size of each data set small, and then we've kind of been incrementally increasing that as we kind of evolve the tech. When we first launched, we were basically, we were using a off-the-shelf open source triple store, our RDF database, and we had written a little bit of a custom orchestration code to load an elastic cluster of those servers, and we found pretty quickly that it was going to be really hard to kind of maintain that account level scale. The query engine was great on it. The loading of data in bulk as things kind of changed was getting to be just too unpredictable, and the spikes were hard to manage, and it wasn't something we could just kind of push to being completely asynchronous. So we did kind of a major revisit of the query architecture, and we ended up using a really interesting technology called HDT, which stands for Header Dictionary Triples, which is a binary RDF serialization. It has the nice characteristic that the way the files are organized, they're queryable in place. So what that meant for us was we were able to basically build I say a custom query layer, which is true, but it's custom in the sense of it's orchestrating together a couple of really great open source components. We basically are, we store, as we ingest data, we convert it to RDF, serialize it out to HDT files, which we store on, really cheap cloud storage. We have a network file system layer that we use as our cache, where we basically load data onto that fast NFS layer when it's accessed, and then we have a custom query layer that uses Apache's Jenna open source Sparkle engine as the query engine over those files. And this has given us just a inexpensive, easy to operate kind of at the network economics level query layer that will scale out linearly very, very easily.
And what are some of the technical challenges that you've been faced with that are unique to the task of being able to host such a heterogeneous assortment of data sets and their intended shared use case?
One of the reasons we chose the semantic web tech and RDF for this was it's a universal data format. If you think about how triple stores, databases like this are organized, everything is kind of broken down logically to statements of the form subject, predicate, object. It's all kind of broken down into atomic facts. And so as we start thinking about adding new types of files, it's really, in a certain sense, it's as simple as how do I parse that file format and build a model of it into that RDF graph. That's enabled us to support a lot of file formats. There's a lot more that we could continue to support that way. The things that doesn't handle are things like spatially indexed databases or free text searching. So one of the things that we're starting to experiment with is how do we layer things like a spatially indexed database alongside this Sparkle queryable graph database, and allow people to really, when we parse the geospatial files that we do today, we're able to pull out a pretty useful amount of information. We can pull out lat longs and bounding boxes and some sort of geospatial queries that are relatively straightforward to answer, and we can pull out all the tabular topical data. But if you want to really do true polygon matching, you really just need a spatially indexed database. There's not much else you could do. But and then you also mentioned the shared use. I think something that we've spent a lot of time on, and I think I'm really happy with what we have. I think we have a good flexible format here, a good flexible platform for this, but this is something we keep working on with groups of users. It's just that access control model, thinking about what does a distributed access control model with groups and how do you kind of optimize for both making it really easy to share data with groups of people and distribute in as open a manner as possible, while at the same time realizing that, data security, data privacy are some of the most important things on people's mind when they're working with data. And so when you need to keep a set of data private or secure in some other way, that's going to be one of the most important things on your mind. And so how do you kind of support both?
And that leads nicely into the topic of managing the privacy or compliance of some of the data sets that are loaded onto your platform, particularly if they're intended to be hosted privately. But if they are hosted publicly, how do you ensure that there isn't personally identifiable information in that data that needs to be cleaned out?
Yeah, it's one of the questions we get asked the most, and I'll throw one more facet into that question before I answer it, which is also particularly important for open data is licensing. There's not one size fits all open data. It'd be great if all the open data out there was just simply public domain or Creative Commons 0, but that's not necessarily the case. A lot of data is open, but it still comes with some amount of restrictions on its use. And we think about these things, I guess, through two lenses. One is that, with respect to issues of privacy, compliance, security, access control, we are doing the same things that any cloud hosting provider who's managing user data on their behalf is, which is, and so with respect to the concerns about, can I trust that you're keeping my data private from other users, you're keeping it secure, that it's not going to leak into other hands. We could go through all the things we do there, but it'd be the same things that any company would say they're doing to protect that. The issue really comes more into, are we guaranteeing that that one of our users isn't putting data that has people's private information or that is not compliant with licenses or other usage restrictions? And we look at that like any kind of internet hosting provider would, which is I can't I cannot necessarily control or stop everything that somebody publishes using my platform, the same as, a web host provider couldn't stop somebody from taking that same data set, dumping it as a CSV and posting it on a web page somewhere else. We have a process and all the steps we need in place for taking things down when we find things that are posted outside of usage restrictions or that contain PII that shouldn't be there. But we basically do pass that responsibility for posting things and keeping them in compliance with the rules of the use of that data to the users.
And for the data types or the data formats that people upload that are not able to be automatically converted to RDF, thinking particularly of things like PDFs with embedded tabular data or prose text or audio formats that are difficult to parse in an automated fashion, what are the ways that you expose for people to be able to add additional information to make those pieces of information discoverable and add contextual relevance to the structured data that they're uploading?
One thing we've seen happen quite a few times on the platform, and something that I think is really kind of goes back to the core idea that data can be iteratively made smarter and more contextual and have more knowledge embedded in it, is, we've seen a number of times where somebody has posted, a PDF or a set of images that, that contains some structured information, but that wasn't easy for that person to pull out in an automated fashion. And we've seen another user come along and say, oh, this is great. This PDF or this set of images had tables of data that I was really looking for, and I went through the process of either applying some OCR software or using an open source project like Tabula to extract tabular data from PDFs, or in some cases just hand transcribe the data and share that structured version of the data asset back. And so you kind of had this world where if somebody had the data and shared it because they thought it might be useful to somebody else came along, found it and said, that's useful to me, but only if I turn it into structured data. And I've now done that. Let me share that back. And so you have both of those assets sitting alongside one another. That provenance, that data lineage is there. So if somebody ever questions whether the structured version is a true representation of what was in the original, the ability to go back and reproduce that is there for anyone who has the wherewithal. I think over time, things that we will likely end up doing is some amount of automatically handling some of those things. We've experimented a bit with maybe making something like Tabula part of our ingest pipeline, where if we can find some easily identifiable tabular data in a PDF, we can extract it out. And you can do that with some degree of success. You can also end up with a lot of really questionable result data that's not quite it's almost less useful than doing nothing if you end up with extracting out bad copies of data. So it's something I think we'll keep experimenting with. Certainly something I would like to do more of is some natural language processing on free text data, PDFs, documents, or even just the textual descriptions that people add to do more topical analysis, kind of understand some of the entities and the categories that are represented by that data. And again, one nice thing about having the backing of every data set be a graph database is that as we start doing that kind of metadata extraction, it just naturally can get added to that data set and make the search across that data a little bit smarter, one piece at a time. We don't ever have to kind of do a big bang of now we support this whole new feature. It's there are certain kinds of metadata that you could extract from natural language, and as we get better at extracting it, we have a place to put it where it's immediately queryable.
And for people who are running analysis against the data on your platform, are they generally connecting to it via an API if they're trying to do something more programmatic than just using the Sparkle query language for trying to fetch data from it? Or do you have some capacity or capability for people to be able to submit a programming task or a analysis task to a set of executors that will then run co-located with the data?
Yeah, it's great question. So we don't have any sort of hosted computation that runs co-located with the data. It's definitely something that comes up. I think it's something that we'll keep looking at, especially as we start accumulating larger and larger data sets. What we do have APIs for accessing the data, and most people doing analytical work on the platform are using those APIs. We have a set of web APIs that cover basically all the functionality of the platform and provide a number of different ways of getting data both in and out. And we have SDK wrappers for that in Python and R, which a lot of users use those with just personal access tokens to do ad hoc work. So if you're working in Python or R, you can pull in those SDKs and treat really any of the tables in any data set as a data frame and act on it in place. Be able to push data back up into the data set as a result of computation, or pull data frames down. You have access to that SQL and that Sparkle layer through those APIs. So if you want to do joins across multiple data sets and pull those into data frames and operate on them, you can do that. And then using the Python SDK, there's actually quite a few Python SDK and then other language targets that are just accessing those web APIs directly. Quite a few other connectors that are available. One of the most popular ones is the Tableau Connector. So folks who want to do analysis in Tableau can connect directly to data.world data sets and produce reports, visualizations that way. We just launched into the Microsoft App Store an Excel connector. One of the things we started observing is that while you can just take an Excel spreadsheet and drop it into a data.world data set, and that works great for kind of clean, well organized data sets in Excel format, a lot of spreadsheets don't really follow that norm, right? A lot of times your spreadsheet is just as much kind of an ad hoc database interface that you've evolved as it is a place to store the data. And so when we built the data.world connector, it really lets you work with richer, more complicated spreadsheets in a way where you can start to actually bind the data tables that exist in those spreadsheets back to data.world data sets and in a much more natural fashion. So and we make all of these connectors open source. So we've already started to see a number of places where community members have looked at our connectors that we've published and use those as a jumping off point to go take some of their favorite platforms and start to build connectors into those.
And what are some of the new capabilities or improvements that you're planning to implement into the platform?
So internally, we're kind of organized around three principles. And there's the engineering teams kind of center around these. We think that working with data should be collaborative, so that we need great features for people doing team data work. It should be linked, so that we're always increasing the amount of connectedness in the data itself and the number of data sets that each data set's connected to, and it should be connected to external tools. That the idea there is really just that there's such a huge amount of investment today going into data tools. For a platform like ours, where we want to kind of be the collaborative hub for how people are working together on data assets, we need to interact with as many of those tools and platforms as possible, because we don't want to be in the business of trying to change completely how you work with data. We just want to enrich it and help you make your data smarter over time. So across those three, the team working on collaboration is really working on what are the tools that help a team of people work together. And a lot of that right now is just, what does our organizational access control layer look like? What kind of features do you focus on when you're looking at your team's dashboard, your team's library of data? Our data team are working on, we build all of this data into a linked RDF database. We're now really kind of making good on that promise of, as you're working with data, we're capturing the results of that work you're doing and turning that into rich linked data, taxonomies, ontologies, basically highly structured descriptions of what your data means, and starting to surface those features back out to you. And so, really fulfilling that flywheel I talked about earlier of, if you've uploaded a spreadsheet that has a column of 5-digit numbers, that we can look at those 5-digit numbers and say, well, these aren't 5-digit numbers, these are zip codes. And zip codes are actually a real world entity that has some indicator of geospatial extent. And I can start to find you related data that actually is broken down by the same zip codes. And so you could, for example, traverse from your data to the US Census, and the fact that you have your data broken down by zip code, I can help you aggregate and break that data down by racial demographics or economics. A lot of those features are the things that are going to be coming out in the near future. And then just with respect to being connected to outside tools, I think the things that are coming down the line there are really just fleshing out the whole data lifecycle, so that our tools can if you're working in an external tool like Tableau, like Excel, you can do more and more of your work there, so that if you've linked those tools to data.world, you can really stay in your tool of choice and come back to our data.world web platform only when you need to maybe like kick off new work or interact with some of the tools there.
And going back briefly to one of the things that you mentioned as far as being able to track data provenance, I'm wondering if you are versioning the data sets as they are updated or modified by the people who are maintaining them.
Yes, we are. We're versioning every change, both at the granularity of the data sets, also to a lot of the individual assets. So saved queries, the insights that you publish alongside the data. We don't, and this kind of ties into the some of the work coming out of the team working on the social features. We don't surface as a lot of the versioning right now, and a lot of that is really just working through a lot of user tests and figuring out what is the model of versioning that makes the most sense for teams that are doing this kind of data work. We're capturing all that information, and we've kind of got full replayability in the model that we're using. But what we're finding through user tests is that if we just kind of expose something as rich and complex and with all the same kind of features as Git, it's not really the way that non-programmers find easy to think about versioning. And so we're looking at some other models of how that data lineage can be displayed, and it's not just displaying the lineage, but then what are the operations you can do with that lineage, right? Do you want to be able to roll back to a point in time? Do you want to be able to tag a particular version of a data set and say that you can do reproducible queries at that version? I think yes to both of those things. I just think we have to figure out how to communicate that to users in a way they can understand.
And given the breadth of the capabilities and target that you've got for data.world, what are some of the other projects or companies that you consider to be competitors in the space?
Yeah, we think about this a lot. We kind of look at the different segments of data tools and try to think, and we could see ourselves to some degree intersecting across a lot of those segments. One thing that I think is fairly unique, and I think is kind of the focal point of what we do, is just the social network aspect. The fact that it is an open platform, we can build closed networks within that open platform. So teams within companies are forming organizations and working in private, but still kind of having access to that broader network. The tools we definitely don't want to consider ourselves in competition with is sort of the visualization and kind of reporting analytics tools. We think there's so many great tools there that we really want to be as compatible as possible with those. There's platforms for data cataloging, metadata management, and those have some similarity and overlap with what we do. but I hate I hate saying like I don't know that we have something I consider a direct competitor, but almost every company we look at, we can think of, I can think of potential customers who might choose to go with another tool instead of ours on a given basis. But I can see ways for a data.world a data.world organization to be a good complement to almost any data tool out there.
And with the variety of data that you have hosted on the platform and the broad number of people who are interacting with and enriching those data sets, what are some of the most notable or interesting or unexpected uses of the data.world platform and analyses that have come out of it that you're aware of?
Yeah, so one thing that I was really kind of surprised by and really happy with around the end of last year, a group of folks who were motivated by a lot of the developments in our political climate to start an organization of data workers to really pick up a lot of social causes and try to address social projects with data and with analytics skills, called Data for Democracy, founded by a pretty well-known data scientist named Jonathan Morgan. Started up, and they early on connected with us and started doing a lot of the teams working on Data for Democracy projects started working on data.world when we were really only a couple months old as a platform, and they were just getting started as a network. And within about 6 months, that organization grew to well over 1,000 people. I think it's over 2,000 people now. And I can't quote you the number of users who are on data.world at this point exactly, but I know that when they were about 1,000 people, we had about 700 active users as a percentage, and as far as I know, that percentage has kept pretty intact. So a lot of people doing and these are people who are a lot of them are students, a lot of them are professional data scientists, business analysts in their day jobs. A lot of folks who were kind of interested in learning data science and using this as an ability to have some real hands-on experience and work with some smart people to kind of teach them. So, we just see a lot of really, really great kind of groups of people coming together to work on projects. And it was fantastic for us in the early days to have just such an active group of people giving us feedback on the platform and helping us kind of understand what this, data teamwork looks like.
Yeah, that definitely sounds like a very interesting and worthwhile usage for the platform. And you mentioned Jonathan, who I have had the pleasure of meeting and speaking with before as well. And for those who aren't aware, he is one of the hosts of the Partially Derivative podcast, which is another one worth listening to. So thank you for bringing him up as well. And a fellow Austinite, if I'm not mistaken.
That's right.
And are there any other topics that you think we should cover, or anything about data.world that we didn't touch upon that we should talk about before we close out the show?
No, I think I really appreciate you inviting me to come on the podcast, and I think you asked some great questions and really kind of covered the ground of what we're doing. I think we're doing something pretty unique in the data world, and I think there's a lot of interesting tools out there, and I think we're finding a good place in that pantheon of data tools, and it's a lot of fun. It's definitely a really rewarding thing to be doing every day, and I really appreciate the chance to come on and talk about it.
All right. And for anybody who wants to keep in touch with you and follow the work that you're up to at data.world and elsewhere, I'll have you add your preferred contact information to the show notes. And as a final parting question, from your perspective, what is the biggest gap in the tooling or technology for data management today?
Well, unsurprisingly, given everything I've said about what data.world is, I think the biggest gap is in keeping context and knowledge with data. I think most of the data out there really has only a very loose notion of what it actually means, and it requires a lot of extrinsic information that really is trapped in human heads to make sense of it. I think we focus a lot on the semantic meaning of data and how do we capture that knowledge and that semantic meaning alongside the data. I think in a lot of ways it's what machine learning folks are thinking about. They're just using different words and kind of inventing different technologies for it. I think there's going to be a real convergence in the next couple of years around really leveraging this idea of semantics and knowledge management. Both for data that's being worked on by people, but also in furtherance of making data more accessible, more usable by machines.
All right. I'll let the listeners think about that as they go about their day. And I want to thank you for taking the time out of yours to join me and talk to me about the work that you're doing. Data.world is definitely a very interesting platform. I joined it a little while ago, so I've been getting the regular newsletters of the new data sets as they're added. And there's a lot of interesting things that, given the time, I would like to do some analysis of. I'd also like to point people to the blog that you guys maintain, because there have been some very interesting articles coming out of that. And I just want to thank you again and hope you enjoy the rest of your evening.
Thank you very much. I appreciate it. And I'll just take that moment to remind folks that, data.world is free to join and sign up, and it always will be. So if you're interested, please just go to the website, data.world, and create an account. And thanks very much for inviting me on.